Okay, so this is the complete Arduino circuit for the soil preparation robot. It uses one Arduino and a breadboard for connections and a 9-volt battery for higher voltage supply to the motors. So let's see the code first. Obviously, we include the servo database. We have an ultrasonic sensor. We have a moisture sensor, which also acts as a proxy for a soil density sensor. Then we have this potentiometer, which acts as a proxy for a pH sensor, since that is not included. We have a servo motor for the probe arm. We have a right and a left track motor for forward movement of the entire robot. And this DC motor right here is for the tiller. These are driven with 2 motor driving chips, since each one can only support 2 motors. So here's the code. The functions are defined down here. We have the find distance function for the ultrasonic sensor. We have forward and turning functions, as well as the start and stop functions for the tiller. So basically, let's just start the simulation. Okay, so everything takes a while to start here, and I've noticed that there's quite a bit of delay. I'm assuming this is because of Tinkercad itself. So as we can see, the servo actuates the probe arm at specific time intervals, and these are pretty fast for now. They can be tuned as well to be more reasonable, but it takes them at constant intervals so they can get a complete picture of the soil parameters constantly. And we'll later see how this information is broadcast to the other robots and how the conditions are recorded in the code. The first thing we're going to talk about is the navigation. So as you can see, both motors are moving forward at the same speed right now. But let's say that our robot encounters an obstacle. So as this obstacle comes within 20 inches, let's see. We should see our motors stop, and then one of them is going to reverse direction, causing a right turn. And this is gonna cycle a bit, so the robot turns 90 degrees, and this cycle right here repeats until the obstacle is cleared of the 20 inches, based on the ultrasonic sensor here. So in a few seconds after the delay, we should see right here that the 2 motors return to forward movement. Now, as for the tilling arm, we use this sensor right here. Right now, the soil moisture is very low and the soil is very compacted. So as we can see, our tilling arm is actively tilling and loosening the soil. If conditions were good and did not require tilling, we should see this motor stop moving in a second. And here we go. Now, if we go to our console here, we can see that the soil conditions are actually mapped here. And this data is combined with the GPS data to create a soil quality map. Now, this broadcast here is based on both the moisture/compaction levels and the pH of the soil. So here we can see our pH is good. It's in the high level, so it's not acidic, but our moisture is low. So if we increase this, since both of these are in the optimal range defined here, we should see the soil conditions go to good. And here we can see it update. And this information can be used by the seed deployment robot to find optimal planting positions. So if we drag one of these down, actually let's use the pH as an example, like this. Increasing it to some acidity, we should see the soil conditions also drop. And there we go. So here's a slow scroll of the code